Welcome everybody. I appreciate it's a very busy time of year, particularly if you're teaching in a classroom. So I appreciate that you've come along this evening to listen to a little bit more about task design. So this is actually our third in a series of mastery focused TeachMeets. If you haven't been to the others or you wanted to find out a little bit more, they are available on the TeachMeet area of the Twinkl website. And I think I've dropped some links in here as well if you wanted to go back and have a look. This particular session is focused on task design, so how we can use intelligent practice when we're thinking about activities that we're going to do with our children. To start off with then a little bit of background from me. So I taught in primary schools for 19 years. I taught at 3 very different schools in my local area, and in that time I was also Key Stage 2 lead, and I led maths as well. Towards the last 4 or 5 years of my career, I had a real focus on mastery. I was lucky enough to be part of a teacher research group with my local maths hub, which was really the best CPD I'd ever had. You know, once you've been teaching for about 15 years, you start seeing the same things coming around, but it was the thing that most changed my pedagogy and something that I'm really passionate about now. And therefore I do have some experience of delivering CPD in a variety of settings on the subject of mastery. So as I mentioned then before, this is just a little outline for you of what we're going to talk about today. And I'm hoping that the session is going to be about 45 minutes, so we might finish a little bit earlier than planned. We'll just have a quick recap on maths mastery. As I mentioned, we do have a full TeachMeet, which is focused on what maths mastery is. So if you do want a little bit of a refresher, you'll be able to find that on the website. I have managed to squeeze it into a couple of slides just so that we can make sure we're all on the same page to start today. We're then going to talk about differentiation when teaching for mastery. One of the biggest misconceptions about teaching for mastery is there isn't any. Of course, there is differentiation. It's just not traditional differentiation, which will bring us on to thinking about how we design our tasks to meet the needs of all the children that we might be teaching. And we'll talk about variation theory in that. And then we'll spend a bit more time looking at 2 resources that have been very much designed with conceptual and procedural variation in mind. And then we'll finish off. I'll share some links for you and we can have any questions. So that link down at the bottom there is the link to the very first Teaching for Mastery TeachMeet that we did. We also did another one on challenging and supporting in a whole class setting. So those are available for you. But I have just recapped on some real key elements of mastery here. So this first bit is the bit from the national curriculum. So because it's not in the programme of study, it's at that beginning bit of the national curriculum, it's often not discussed, but this is where mastery comes up. They don't use the word mastery, but this is where they talk about the essence of mastery learning, and so it is there in the curriculum. I'm not necessarily going to read everything on the screen today. I've included lots of text so that you can go back and have a look at it for yourselves, or share it in your setting if you need to. But I will try and bring out the main parts, and I've boldened where possible to make that a bit easier. So broadly, the same pace is something that lots of teachers who have been teaching a long time found quite difficult at first. There had been a very high focus on maybe having cutaways and differentiated groups based on preconceived ability. So that for Curriculum 2014 was quite a big thing, that everyone should be going through the content at the same pace broadly. And what I'm not necessarily talking about are outliers, or maybe children with EHCPs, or children who are severely below or above their age-related expectations. But generally in a class setting, we're talking about the whole class. And it's about securing mathematical understanding, so that actually what we're not doing is just motoring through content, and then finding that actually the understanding wasn't there. I'm lucky enough also to have had some experience of tutoring at Key Stage 3 and 4. And it is amazing the knowledge from Key Stage 1 and 2 that came up in the revision for GCSE. You know, you think it's so far removed. It really isn't. Having that secure basis, like the bottom row of a house of cards, is really, really important to children's mathematical success later on. And it can be difficult because you don't necessarily see that at the end of Key Stage 2, for example. You were obviously still very much judged on SATs results, but it's really important to realise that actually what we want to do is to make children have a really secure understanding of maths and make them really good mathematicians. This is interesting bit. So it's about challenging children who grasp concepts rapidly. I will try to avoid using ability terminology in this presentation. We're talking more about how quickly children maybe get through the concepts or the tasks. It can be quite difficult, but it's really, for years and years, people made assumptions about what was termed as more able mathematicians. And actually, a lot of it is having very good memories. And although, of course, there are a lot of very able mathematicians in our classrooms, it sometimes it can be quite damaging to make some assumptions. So that's just as important as supporting at the other end as well. And then talking about making sure that we consolidate and we practice and we make sure that those understandings are really secure and clear before moving on. So that's just that little snippet from the national curriculum to remind us why we're doing it. And then again, this is a truncated version of a whole TeachMeet, but these are some of the key elements of teaching for mastery. I'm not claiming to have them all, but these are the ones that are relevant to what we're doing today. The assumption is that all children are capable of succeeding as a result of working hard at maths. Everybody can do it. And that's very much linked to growth mindset, isn't it? And it can be a very difficult challenge for us, particularly if our own mindset towards maths is not as strong as it could be. And if parental mindset is not as strong as it could be as well. So a constant battle, but a really important one. That significant time is spent developing knowledge. We're not just saying, well, our plan says on Tuesday we're moving on to this, so we're moving on to this, but we're really making sure that we've got that secure understanding of those key elements. Small steps of learning, and we're very lucky today because there are lots of small steps schemes of learning out there for us to use, and so that part is kind of done for us, but it's really important that we incorporate conceptual and procedural variation, which I will go on to talk about in a bit more detail shortly. Again, this is something that maybe was a little bit of a culture change, is that whole class interactive teaching is taking place. So we're not maybe sending a group out with another adult or sending a group to start a task, but everybody's together on the same content at the same time. Now, of course, that's a very difficult task to challenge and support such a big group of children as a whole class, if that's where you're teaching. But it's really important. And as I said, there was a support and challenge TeachMeet, which focused on how we can use questioning to support and challenge within one session. It's a difficult task sometimes to teach a whole class at once, but it's having those little tips and tricks to make it easier. This is really important. High expectations for rich vocabulary and communication. And I will reiterate that it's not just the children that we're expecting that from, it's all of the adults in the room as well, making sure that we're modeling really rich vocab and giving the children the tools they need. There's a real focus on reasoning in today's maths curriculum. And I think often we think that means the children need to write something down. But in the same way as with English, you wouldn't expect children to be able to write it before they can speak it. It's very similar with maths. It's really important that we're modeling that vocabulary and giving the children that vocabulary that they need. This is one that has been adopted really, really well in schools, particularly with the CPA approach of concrete, pictorial, abstract, but making sure that we're using representations, models and images throughout, and it's not just the abstract. And again, that's not just for one group of children, but for all the children. One of the biggest issues with solving multi-step problems is that they're so abstract. As soon as you introduce a bar model, it can make life a lot easier. So representations are useful for all, not just a subset within your classes. And we mentioned it already, but effective questioning is really important, making sure you're really pulling out that understanding. And we'll talk about that a little bit further in this session. And again, something which often I think gets missed because we're trying to spend time securing is that not everybody necessarily gets onto reasoning and problem solving tasks. However, if you're teaching for maths mastery, really you're reasoning all the time. You're expecting children to reason orally, you're talking, you're discussing, you're collaborating. So it's not just being able to answer a written question at the end of a lesson. It's making sure that everybody is exposed to those opportunities in your setting. And key facts learnt to automaticity. We know that it can really reduce cognitive load for children to have those facts at their fingertips. For example, if they know their times tables, when they get to some missing number calculations and they're multiplying 2-digit by 4-digit numbers, for example, or decimals, it's going to be much, much easier if they focus on the concept or the procedure rather than trying to bring up those facts. So we do know, and today is going to be talking about not doing the same thing over and over and over again. However, there of course is a place for it. As long as there is a reason for it and the children need to practice, it's absolutely okay to do that if you're trying to improve their recall. That was a very quick whistle stop of the key elements of teaching for mastery. Please do use the questions if you want to ask questions, and we can get back to that at the end. But hopefully that was all quite clear. And we'll move on now to thinking about task design then and how we can incorporate that in our lessons. So one of the biggest questions I think teachers and parents and leaders, probably most importantly, ask is it okay for all children to be experiencing the same task? If you've got quite a lot of teaching experience, you will remember when that absolutely was not okay. And it was, well, hold on, why are these children doing the same thing when they're coming at it from different experiences? Well, just put your mind at rest. And also, if you're on a mastery journey, maybe that isn't fully supported by leaders, or you've moved schools and your new school isn't on the journey yet, this is a really good one to have in your back pocket to show to leaders and SLT that actually it's okay. And we know it's okay because Ofsted has said it's okay. So again, this is a really, really big excerpt from the Ofsted report. I'm not going to read it all out, but in the subject report for maths, which was only last year, so it's very, very recent, Ofsted recognised that there has been a cultural shift. We're not necessarily having the squares, the circles and the triangles anymore, and they're all doing something different. They recognise that sometimes that could be really motivational for some children, particularly if they could choose, but that actually what it really ended up doing was widening the gap, which of course is almost the opposite of what we're hoping to do with teaching for mastery. So they've recognised that maybe that wasn't the right way, particularly if children maybe chose something that wasn't matched to their level of understanding, or that some children never got to that sort of meatier problem-solving area of maths as well. And this is the most important bit, really, that they recognise that in some schools, leaders and teachers said, actually, okay, we're all going to start at the same point, but there's going to be a minimum expectation that everybody gets to this point. And that at that point, we'll know that they've got a secure understanding. But then there's all these other things that we can do to deepen that understanding. In the other TeachMeets, I talked about the great mastery obstacle race. And that's exactly what it is. You know, you're working together, you're going to a predestined end point for everybody. And then there might be some more. But in that bit that everybody's doing, you want to have enough to be sure that everybody has mastered that concept, because that's what we're looking for. And this bit is worth reading out. So pupils experience independent practice that was largely similar, at least at the beginning of sequences of learning, and this was okay. Leaders were aware that doing the same thing can in some circumstances be okay, and that every pupil needed to be familiar with the basics. And I think that's a really important takeaway there. It's okay if you're planning with conceptual and procedural variation, you're not going to have pages and pages of practice. So it's not going to hurt your children who maybe have already got a bit of an understanding to whiz through those. And then you've got your evidence. It's okay. Ofsted are even recognising that it's okay for people to be doing the same thing. So that just answers that question, which I get asked all the time, and I think is a big worry for teachers in schools today. So variation in theory, then, it's not new, and I have put some reading at the end of the slides today that if you wanted to go and have a little bit of a bit more research on it. It's not new at all, and it actually underpins the mastery approach that they follow in Singapore and countries that do really, really well mathematically. Of course, the NCTM are real leaders in providing information to support teachers in this, and they work with the Maths Hub as well. So I've just included a little snippet. Again, there is so much reading you could do around this, but I have just emboldened the little bits that I think are going to be relevant for the next step of our session today. So we're thinking about variation is about thinking about what's going to change and what's going to be kept the same as we work through the learning. So we're not just thinking about having 20 examples of the same thing or doing 20 examples on the board of the same thing, but making tiny tweaks and thinking about what we change to really deepen some understanding, and talking about what the concept is and what the concept isn't. And we'll talk a little bit more about that in just a second. If you are familiar with the 5 big ideas for mastery, variation theory is one of those big ideas, and it is split into conceptual and procedural variation, but it's thinking about that coherent route through an activity, and it's not just thrown together. And I appreciate that teacher time is, and educator time generally, is so precious, and hopefully I'll share some resources with you today that you can use, but it's hard. In Singapore, where this approach is very, very popular, there are whole teams of teachers who are given a really big amount of time to plan these sorts of things out. So, it's not easy, but it's thinking carefully about that variation as you go through. And essentially, we're thinking about what's the same, what's different, and what's changed. And hopefully that is on a level that everybody can access within your classroom. A little bit more about variation. So we're thinking about which examples we're going to use. And today I've tried to choose 2 very different things. I've chosen one poster and one activity sheet, because when we're talking about task design, we're not just talking about what the children are doing independently, but whether you're doing it through a whole class collaborative session, whether you're doing it in a small group, however you're doing your task, it still stands. It's not just for the worksheet at the end. So it's thinking about the examples you use and very carefully selecting them. So we're not thinking about just repeating the same thing, but we're wanting children to start to spot things and make connections. And they will, and they won't necessarily do it without your encouragement, but they will get there and they will start making those connections eventually by themselves. So it's thinking about assisting understanding by drawing attention to the structures and relationships. So as I said before, variation is kind of divided into conceptual variation and procedural variation. And I think when I was doing the Mastery Research Group, this is the area that I feel that people maybe weren't 100% sure what the difference between the 2 were. So that is going to fill in the rest of our session, really. So we're going to talk through an example of each in quite a lot of detail. Okay, so we'll start with conceptual variation, and it's about teaching the concept by varying the representation used. Representations are so powerful in maths all the way through up to Key Stage 4 and beyond. It's not something that we just rely on for children who maybe need some scaffold, but can be a really important maths tool. This is my favourite example, and you see this often in mastery materials, is if you ask children to name the shape on the right, having not shown them the shape on the left, you often will get a whole range of answers. You might get diamond. You might be lucky enough to have some mathematical language and they might say rhombus, maybe, because they've started to spot the qualities of a rhombus. But many children, not all, that would be a sweeping generalization, but would not recognize that as a square purely because of the orientation. So when we're thinking about conceptual variation, we want to think about what are the essential features of the concept. So if we're thinking about the essential features of a square, we'll have 4 sides of equal length, 4 equal angles, and all the angles are right angles. So that's our essential features, our definition, if you like. Then you need to think about what are the non-essential features. If we change these one at a time and show children examples of this, we're really supporting a solid understanding of that concept. So orientation is one. We might also think about the size of the square, whether there's anything in the square, the colour of the square. I mean, even things that aren't mathematical, it's worth showing as many different representations as possible. And that's why it's really important, particularly in the area of shape, to be looking at a whole wealth of examples when the shapes are introduced. It's very, very common to show children a pentagon that's like a house with a roof and a square underneath. And they will often say, when you say, what shape is this? They'll often think, I don't know what shape that is, but it looks like a house. Is it a house? actually it's a pentagon, but they're so used to seeing a regular pentagon that they maybe don't think about those features. So that's really, really important. You'll see how we've done that in one of our resources in a second. Loads of examples, varied, thinking about those non-essential features. Don't just show one example, and make sure that you're completely varying those examples that you're showing. And just as important, think about what a square isn't. And I've mentioned there, it's important to think about, first of all, what obviously isn't a square. Obviously a circle isn't a square, but what plausible distractors might there be? So you might have an oblong based rectangle. Obviously a square is a rectangle as well, but will look very, very similar. But so it's really important to go back to those essential features to make sure we know what one is. Let's put it into practice then. So I've plumped in the middle of year 3 objectives for the examples I've looked at today. I appreciate that we might have a huge range of experiences and year groups that you might teach, or children that you might teach in the room, but I've tried to go in the middle, and the concept is the same throughout. So first of all, we're going to take the objective. And I've gone for this one. That is a huge objective. So we're just going to focus on the bits that I've put in bold. So we're going to focus on identifying pairs of parallel lines. Trying to teach all of that in one lesson would certainly not follow a small step approach. So I've very much broken down that objective there. We're just going to focus on parallel. So, and actually, if you don't mind, you don't have to, but if you don't mind, you could answer some of these questions in the chat as we go as well. If not, I'll just give a little bit of thinking time between, so you can think in your head what you think the answers are. But what are the essential features of a pair of parallel lines? Have a little think about that. And if you're not a year 3 teacher, you might not be familiar with that. Yep, they don't meet. That's one thing. Thank you. There could be some other features that you might think of. There might be one that you find surprising. There's one that is often misunderstood a little bit. Okay, let's have a look. So they have to be straight. We often, don't we, use railway tracks as an analogy for parallel lines. And railway tracks aren't actually only straight lines, but the definition of parallel lines are that they're straight. They have to be on the same plane, and we could get into a very interesting maths discussion here, couldn't we, about the use of that language at Key Stage 2. But essentially, they're straight lines, and yet somebody's already said the next bit, which is they're always the same distance apart. Now, probably worth mentioning, and you would mention this if you were talking to the children about this, whether that you were maybe sharing the poster I'm about to go through on slides and going through one example at a time. When we're talking about them being the same distance apart, we're talking about if the lines continued forever. I haven't put that in here, but just to make sure that's clear for the next bit of the presentation. And essentially, that is the definition of a pair of parallel lines. We could get more complicated. We could say they always have the same gradient. That is another way of saying they're always the same distance apart. And you're not going to harm any of the children at all by introducing that language just because it isn't in the curriculum. However, they don't need to know it at this point. So it's just an extra thing that you might talk about. So I think sometimes I've seen people use that they're the same slope, which is obviously the same as gradient. So those are the essential features then. So it's important that we highlight those first. What are the essential features? Parallel lines are straight lines that are always the same distance apart. And then we're going to move on to think about the non-essential features. So what do you think then, thinking about the non-essential features that we talked about with the square, what might be the non-essential features of a pair of parallel lines? What could we change about the pair of lines that doesn't change the concept of them being parallel? And feel free to put some ideas. Yeah, good. We've got some good ones spotted there. Lines going in the same direction. They don't have to do that. The same starting point. Absolutely. And that is a big one, actually. The fact that they aren't necessarily opposite each other is a real misconception with children. So what I've done is I've pulled out some non-essential features, and I'm not by any means saying this is all the non-essential features, but I've pulled them out and I've provided some examples of each. So these are things that we can vary, but we don't change the fact that they are parallel lines. So the orientation, we can change the orientation of the lines. They are still parallel. So I've started with that familiar representation at the beginning, but they could be vertical as well. it doesn't matter, but it's about making sure the children see all of those. You know, they see parallel lines with different orientations, and they're not just seeing horizontal or vertical pairs of parallel lines. We could, we could vary the distance between the lines, and that's the relative distance between the lines. Obviously, they have to be the same distance apart, but it could be a big distance, it could be a smaller distance. I mean, it could be a really, really big distance. It doesn't matter. This is from a poster, so a bit limited with space, but if you were doing it in your classroom, you could find some parallel lines that were really far apart and really close together and so on. And it's about making sure that children know that it doesn't matter. It doesn't matter how far apart they are, they will still be parallel if they meet those essential features. Extra information. Oh, my camera's gone ever so strange. I'm not quite sure why. I'll carry on because you can still see the slideshow. Extra information between the lines could be different. So you might be shared parallel lines that are part of a shape. It doesn't make any difference, those lines, and for the purposes of this resource, they are marked with arrows, but they might not always be, and it doesn't matter that that's actually two sides of a shape. They are still parallel lines. They might have something completely different in the middle. They might have a circle, or, and this is a really familiar construct later on in Key Stage 3, Key Stage 4, they might have other lines involved as well. Doesn't change the concept of them being parallel lines. Another non-essential feature is the length of the lines. So it doesn't matter if they are different lengths. One could be really short, one could be really long. They could be the same, and it doesn't matter whether the long one is at the top or the bottom or the left or the right. Essentially, the length of the lines is a non-essential feature. And the relative position of the lines, and this is a real big one actually, and a real misconception, is that the lines don't have to start at the same point. They don't have to line up, and somebody mentioned that in the chat. And they might not even be opposite each other. But if you continue those lines, they would still be parallel because they are straight and they have an equal distance between them. We could also have talked about, I haven't provided examples of this, the thickness of the lines doesn't matter, and the colour of the lines. I mean, you'd think it was obvious, but actually show children things in a different colour, show them the different types of lines, make sure they're seeing all the possibilities for what might make a line parallel. Okay, so we've talked about the essential features and the non-essential features. This is the poster that I was just taking the examples from, and there is a link there if you want to have a look at it. We're working on some more similar posters at the moment. And again, you could pull bits out of that for your lesson introduction. This isn't necessarily an activity. The task we're talking about isn't necessarily the activity that the children are going to do independently. This could help structure your lesson input when you're thinking about what a parallel line is. And we did mention before, it's worth looking at examples. We've looked at loads of examples, but also some non-examples. So I've put a curved line in there, which is a really common misconception. I've put a couple of lines in there that if you carried them on, they would eventually meet. And then this one, again, it seems like it's a really obvious non-example, but often, and I don't think it's helped, they both start with a P, but often children get mixed up between parallel and perpendicular. So it could be that that might just be helpful for us to look at. I'm just trying to change my filters and make sure that's not my, see if I can change why I've got this sort of rosy glow. Can you still hear me okay? Thank you. Thanks, Louise. Brilliant. Right. Okay. I'm afraid you're going to have to put up with my with the filter that's on there at the moment. Yeah, absolutely. This is a really good example, actually. Teaching a child, I'm going to share it from the chat, I hope you don't mind. Teaching a child what a dog is. And actually, you can overgeneralize. You've used the example here that every brown animal that's got 4 legs is a dog in your mind. And a really good example used in one of my favorite mastery books, which I'm going to share with you in a minute, is the example of an elephant. You know, if you just say it's a big grey animal, well, then if you see an elephant and a mouse, you're going to know what an elephant is. But when you see an elephant and a rhino, it's not so clear. So yeah, you're absolutely right. It's really important to just share lots and lots of examples. So that is conceptual variation. I mean, that was quite a whistle-stop tour there of what you might do, and that was just one example. But if you're thinking about teaching through conceptual variation, that's all you need to do. You start with the essential features, then think about the non-essential features, vary them. If you vary one at a time, then you can really support understanding, and finish by looking at some non-examples. And having a poster like this on a working wall, or getting the children to create a poster, is a really good way to cementing that understanding as well. So that's conceptual variation, very much focusing on the use of representations. Procedural variation is a little bit more complex, I guess. I think this is the one that's harder for people to get their heads around. So I mentioned my favorite mastery book, and it's there. It's Mastery in Primary Mathematics, a guide for teachers and leaders by Tom Gary. Really, it's my go-to book for when I'm researching anything to do with mastery. And he talks about using questions that have a dual purpose. So when we're choosing questions, we're not just choosing random questions. We're choosing them in a way to allow pupils to both practice a procedure, because we know that's important to practice the procedure, and to draw attention to key learning points about that procedure. And as I said, sometimes those might be really explicitly pointed out by you. Sometimes you might want the children to find those patterns themselves. He uses this example to start with. He's talking about children practicing addition that bridges 10. There's nothing wrong with these examples if you were just doing some practice of recall. 3 examples there of bridging 10, but they don't allow the teacher to make any further teaching points. There's no other teaching points there, really. It's just practice. And as I said before, there is a place for just practice. But if you're really thinking about mathematical understanding and procedural variation, we're going to think about the order of those calculations. And he then shares this example. So you can see there, those are still calculations that we'll all practice bridging 10. The first set, very much doing that 2 digits and add 1 digit. The second set, slightly different. But by using those calculations, you're allowed children to practice the concept, because that's what they're doing. But also there's an opportunity there, isn't there? And you will have to use that opportunity. It might be that you let the children do it first and then come back to discuss in a mini plenary or a discussion point. You might do it with the children to really focus everyone's attention on there. But the opportunity is there, because then we start to make generalizations about adding. Actually, when one addend is increased by 10, what happens to the total, and so on. So it's about making the most of every opportunity. A lot of teachers I talk to say it's a real struggle to fit everything into the curriculum. There's so much we have to cover, and there is. But making these patterns, making these relationships and spotting these patterns can be really, really powerful. This is just an example of one of our number bonds resources. So again, you can see it's a part whole model. So we've used those representations. The first 3, you don't need really more than 3 of the same thing. If the children can do 3, you probably can be sure that they understand what they're doing. But then if you look at the bottom, the next section, the total was changed to 20, and the addends have also increased by 10. So children might be able to spot something from there. And again, if it's an activity sheet you're looking at rather than a poster like before, or teaching slides, you might have a question to bring that out. What do you notice is a really, really powerful question in mastery teaching, encouraging children to notice and remembering that they don't necessarily have to write it down every time. I know it's very difficult when you've got to provide evidence for things, but that maths talk is really, really important. And then you can see how it's got a little step further down there, looking at number bonds to 10. Just another example from the same sheet there to think about how things are related. And they're not just 5 random numbers chosen for bonds to 10, 20 and 100, but there's very much exploring the relationship between them. And that in itself is a huge discussion, isn't it, for you to be having with your children. And hopefully, because of the nature of it, and you're starting with number bonds of 10, it's very accessible as well. So let's have a look then at another activity that we've particularly designed with procedural variation in mind. And again, apologies, I've gone for year 3 because it's slap bang in the middle. And I've chosen the objective, recognise and use fractions as numbers. Again, that's quite a big objective, but you'll see as I go through how I've sort of focused it down. So this time it is an activity sheet. So it's very definitely a sheet which children will be asked to complete, whether that's after you have gone through a very similar process as a whole class, or whether you're doing it as an assessment piece. You know, educators can choose to use it how they like, but it has been designed with procedural variation in mind. So it starts with a worked example. That is useful for everybody. You know, it used to be that there might be 3 levels of activity sheet, and one of them had an example on, the other 2 didn't. It's not going to hurt anybody to have that example there, and it's a really good thing for children to refer back to, and really, really important, including that STEM sentence there. So you've got a simple example, you've got some key vocabulary there with numerator and denominator, and then you've got the STEM sentence. The whole is divided into 5 equal parts. One of those parts is shaded, the denominator is 5, and the numerator is 1. Essentially, if you understand that, you're going to be able to do quite a lot with fractions. And I think fractions is one of those things, isn't it, where you speak to parents at parents' evening, they maybe say, oh, fractions, I was never very good at fractions, or teachers will say, oh, it's not my strongest area. But actually, it's got some really clear essential features that you can look at, and if you know those and can apply them, then you've got it. It really isn't that monster, but it's actually a really good way of spotting patterns as well. Then after that, we've provided the STEM sentence again, this time with the gaps in it, so that you can see how children might use it. Now, it isn't necessary for children to fill in that STEM sentence every time, so you don't necessarily have to encourage the children to write that every time. If you're encouraging to do that, what you're probably going to do is slow down the learning of some of the children in your class. Have it there, expect it, and you know, in a mastery classroom, what you would hope to see is when the children are working independently, the teacher has time to patrol, helicopter, whatever you call it in your setting, and you'll be able to go and have those conversations. Well, how do you know this? And hope that they would use that STEM sentence to help them. So we've included an example, key vocabulary and STEM sentence there, and then we move on to what we want the children to do to show that they've got an understanding of what fractions are as numbers. So the first part of the sheet is to use STEM sentences to write the fraction of each shape that's shaded. So the shapes are given. This first shape has been chosen because it's identical to the example. If I just go back so you can see, it's identical to the example. It's the same size. It's got the same number of equal parts. The only thing that's changed, this is really important, which is changing one thing, is the fact that there are now 3 parts shaded rather than that 1. So we've only changed a tiny little thing. That should be really accessible now because we've so similar to the example, and you can use a STEM sentence to help you fill it in. Then we might think, okay, well, now let's test that understanding further by altering another thing. So we're going to keep the pieces the same size, and we're going to keep 3 that are shaded. So the numerator is still going to be 3, but we're going to make the shape bigger and split it into more equal parts. So the denominator will change. So it's the same concept. We're shading or recognizing shading of fractions, but we're just changing one thing so the children have a really good understanding of the concept. And then this one, again, it's the same, very, very similar to the one above. It's the same size, but this time those pieces, there's 4 pieces shaded and they've been spread out. Because you can get, sometimes if you get a partially completed problem, children panic because they haven't shaded from the left. Doesn't matter. They don't have to be adjacent. That's a really good way of showing that to the children. This, again, thinking about those non-essential features, this is an orientation one. Just because that bar is now turned around, it's still exactly the same concept, different orientation, same shape. So we're noticing that actually that orientation doesn't matter. It's a non-essential feature of a fraction. Doesn't matter, or fractions of shapes, I should say. Doesn't matter if that changes. And then thinking about summing up that section, if you like, you've got some examples here of different shapes. And there's only 3. There's not loads and loads of them, but they are showing that children can maybe apply what they've just learned with those bars. And of course, you may find that some children in your setting might need 2 examples of each. But what I wouldn't do is have so many examples. It ends up taking a really long time to get to this point, because you could argue by the time you've got to the end of this point, and hopefully the steps have been so small that everybody would have got there, that might be where you say, actually, that's a really good understanding at that point. So that's where I want every child to get. And the last one, of course, is this is not a lesson about wholes and parts necessarily, but the last one, you will have children who might notice. I think the sheet actually has what do you notice on it, that they might notice that if the numerator and the denominator are the same, it's the whole shape. And again, it's about encouraging that pattern spotting from those children. That's a conversation you might have. Yeah, exactly the same as we looked at earlier with that square. Just making sure that children are really familiar with all those representations. So the sheet goes on then to looking at, we're not just shading fractions of a shape anymore, but we're looking at how it might be objects. This might be the point where you think, actually, not everybody's going to get to this point, but we're going to do it in the same way, so it's as accessible as possible. So we've got, it's very clearly 6 equal parts still, and there is one of them shaded in. So hopefully they'll be able to use that STEM sentence. Again, it's the same sentence, even if it's not a shape anymore. And then we might think, okay, well, what if we started to think about giving the children a denominator that isn't the same as the number of shapes? So that example does have 10 equal parts, but you also could say, well, actually, there's 5 circles there. And you might have children who don't get to this point, but you will certainly have children that will be able to spot that. And they're starting then to understand the concept of fractions and equivalences. You're not explicitly teaching it, but they're starting to spot those patterns, which is a really, really important skill in maths ability. And then you're going on to maybe one that doesn't start with a denominator equal for them, or thinking about slightly different. But again, you can see that I haven't varied the shapes I've used, and I haven't varied the denominators. I've just varied the representation ever so slightly, just changing one thing and keeping everything else the same. Again, same thing now. So almost identical to the one before. The denominator is given, and then the denominator of the whole shapes are given, but this time it's squares to show that that non-essential feature doesn't affect it. And a very similar one again, this time taking away that safety net of having the denominator necessarily given to the child in the first place. And you will find that children will start to say things, spot things and notice things. And that's what is going to help them with a real secure mathematical understanding later on. So that is what the sheet looks like so far. So we've shaded fractions up to that point. And again, you might think, well, actually, if they can do that bit on the left, they probably don't need to do that bit on the right to show understanding. So I might not make everybody do that piece, but it's a real good way to deepen understanding for some children. And then we go on to doing the opposite. So we go on to giving the fraction, and the children have to shade the shapes. And, you know, we have lots of resources on site which involve shading fractions, but this is a really well thought out one for teaching the concept rather than practicing it. Same STEM sentence, it's just the other way around. So it's got the denominator is and the numerator is, and then the whole is divided into equal parts, and of those parts is or are shaded. So just a recap there of how they might use the STEM sentence. Notice there's no expectation on the sheet for them to fill in that STEM sentence. It's just there to help their thinking, structure their reasoning in their heads, or if they're working collaboratively. And then we do something similar. So we've got a familiar shape now. We've gone back to the bar. It's already divided into 3 equal parts. So hopefully children will spot they need to shade one of those. Then we've got a familiar shape. We're changing one thing only, and that's the denominator. We changed the amount shading as well, but essentially it's the same shape. We're going for a different denominator. Then this is an interesting one. So this one is the same, but some of it's filled in for them. So they're again hoping to spot that you don't have to always shade from the left. And then same thing again, exactly the same as the one above, but this time it's a circle. And it's worth pointing out that I think circles are often a go-to when we teach fractions. Much easier to start with bars because you can relate them to number lines and bar models as well. But children love to draw a circle and try to split it into equal parts. It's not an easy task, especially if you're doing 5. But that's there to show that it's the same. And then we're moving on to the set again. So we've got the set rather than the shape. We've got the denominator that's given, the denominator that's slightly different. There's no necessarily showing them where that demarcation is. Then we've got a denominator that doesn't match the equal parts. And then you've got a non-unit fraction of the same. So notice that we're changing one thing at a time. We're not just having a sheet worth of examples of all the same thing, but essentially they're shading fractions, or they're identifying shaded fractions in the shape. That's what that part of the sheet looks like in its entirety. So hopefully you might have children who only got to the bottom of the first sheet. They might miss out the next bit and do this bit, or you might let them do it all and see how they get on, because you would be surprised. I mean, I think the children who maybe struggled a little bit before with maths were the ones I saw the biggest improvement in their whole mathematical mindset when we moved over to Teaching for Mastery, because everything was more accessible for them, and the tweaks were so tiny that they didn't even notice, and suddenly they were doing something that was quite tricky. And then after that, the sheet goes on to a bit more of a reasoning element this time. So thinking about giving an example. Sam thinks that each image represents 3/4. Do you agree? So that is where you might expect children to do a bit of writing or discussion, either way, but applying what they've known. And there's all sorts of different examples there, and I've listed why I've chosen those particular examples. We've got non-equal parts, we've got the bits aren't adjacent, we've got the denominator might be different, all different examples to really check their understanding of the concept. So that is the sheet in its entirety if you want to find it. And there you go. Thank you, Lisa has put the link for that sheet into the chat for you as well. So that pretty much brings us to an end then. So we've gone in quite a lot of detail about conceptual variation and procedural variation. Just to finish off, because there's an awful lot to take in, and I've talked, I know, for a really long time. Thank you for those of you that chipped in a little bit in the chat. Just some key takeaways really from the session. We often talk about low threshold, high ceiling when we're talking about problem solving, but it's a really good thing to think about when you are planning any task. Have it really accessible, low threshold, and then think about how you're going to really stretch it for some children who have got a better understanding, or deeper understanding, I should say. So think about maybe what you want everyone to get to, and what that shouldn't be is just fluency. And then maybe thinking about how you're going to challenge and extend so that everybody gets the bit they need to get, and it's not just a certain group of children who are experiencing that. Careful consideration is the key here. What are you going to change, and what are you going to keep the same, and why? You know, I appreciate, again, time is so precious, but thinking about why you did it. When we did mastery at my last school, we had teacher books. So each night my planning was me doing the activity that the children were doing, and it would be full of my notes about what was changing and what I wanted to draw their attention to. And it was also perfect for check your answers as well. So it was twofold, but really thinking about why you've done it. And that also will answer some questions from leaders who maybe don't have such a high understanding of mastery about why everybody might be doing the same thing. Really, really important. What do you want the children to notice? It's worth mentioning that there's not just one right way of doing the fractions activity sheet that I just showed you. We could have gone a slightly different way, and that's fine, as long as you know what you want the children to notice and how you're going to help them to notice it. How are you going to encourage them to spot those patterns? And it could just be by using that "what do you notice?" or "tell me more," or some prompts around your classroom. So those are just a few key takeaways. Hopefully, obviously you'll be sent the slides, so you'll be able to digest it a little bit more later. But that's a little summary of what we've covered. And the final slide, as promised, is just a few little links there for you. There's a link to the Education Endowment Foundation evidence about why we should be teaching for mastery. There's a few links for the NCETM that I referred to earlier. And then we've got the Ofsted report, if you haven't already had a look at it, if you wanted to have a little look later as well. That brings us to the end. So I'm going to finish.